Today we're going to talk about one of the most important topics in the world of computers, something that is behind every app, every game, every website you use. It's called algorithms and data structures. Wait, don't be scared by those big words. Let's break it down and understand what they really mean in the simplest way possible. Let's start with algorithms. An algorithm is just a step-by-step set of instructions to solve a problem. It's like a recipe in a cookbook. For example, if I asked you, how do you make a cup of tea? You'd probably say, boil water, add tea leaves, add milk and sugar, wait for it to cook, pour it into a cup. That's an algorithm. It's not a code or a computer program. It's simply a list of steps to solve a task. There's a famous quote in Computer Science by Donald Knuth. He said, "An algorithm must be seen to be believed." In other words, once you see how it works, it becomes super clear. In computers, algorithms are used to solve problems like sorting your photos by date, finding your friend's name in your contact list, calculating your score in a game. So an algorithm tells the computer what to do and in which order. Now, let's talk about data structures. A data structure is simply a way to organize and store information, so it's easy to find and use. Think about your school bag. You don't just throw everything in randomly, right? You keep your books in one section, pencils in a pouch, lunch in a box. That's a data structure. In computers, we also need smart ways to store information. For example, if you want to store a list of your friends' names, you might use something called an array. If you want to match a name with a phone number, you use a dictionary or hash map. If you're organizing data like a family tree, you use something called a tree structure. Each data structure is good at different things. Some are fast at searching, some are great at sorting, some are good for storing huge amounts of information. So how do algorithms and data structures work together? Imagine you're finding a book in a big library. The algorithm is the way you search. Maybe you start by looking at the category, then the shelf, then the book. The data structure is how the books are arranged, maybe by subject or author or alphabetically. When you combine a good algorithm with a smart data structure, your solution becomes fast, easy, and powerful. Here's a simple real-life example. Let's say you're organizing your Pokemon cards. You could arrange them by number. It's a data structure, maybe a sorted list. And when your friend asks, "Do you have Pikachu?" you use an algorithm to quickly search for Pikachu in the list. Boom, you just used both. Now here's why this topic is so important. Every software developer, every app creator, every tech company, from Google to Netflix, uses algorithms and data structures every single day. They help us make computers think smarter, solve problems faster, and build systems that work at massive scale. In fact, when companies hire programmers, the number one thing they test is your knowledge of algorithms and data structures. So if you're planning to study computer science, if you want to become a developer, data scientist, game maker, or even an AI expert, learning algorithms and data structures is your foundation. It's like learning ABCs before writing sentences. In our upcoming videos, we'll explore different types of data structures like arrays, stacks, queues, trees, and graphs. And we'll walk through famous algorithms like bubble sort, binary search, and Dijkstra's algorithm, all in simple words. So make sure you hit subscribe, because we're going to make these complex ideas feel easy, fun, and powerful. Stay curious, and I'll see you in the next video.